The triple product's the best method of measuring the quality of fusion plasma, or one of the most important metrics for understanding how a fusion machine is going to work or works. And it's a combination of three different things: the product of the temperature of that plasma, of its density, and its confinement time. It's the most convenient way to measure and understand how a fusion machine is working. To be able to fuse two particles, you need to get them close enough, long enough for the strong atomic force to take over and bind them. And that's what holds the nucleus of an atom together. The nucleus of an atom, however, is positively charged. So there is a long distance acting force, the Coulomb force, that keeps them apart. And you can imagine this like taking two magnets and trying to get them close together. And you imagine, how do I get them closer together? You kind of like bring your arms apart and think, I would get some speed on it and maybe I can get them close enough together. And to carry on with that analogy, if you put a really strong Velcro on them, that's a strong atomic force, maybe if you got them close enough, that would hook and they'd bind. And so it's really difficult to get them close together. One way to do that is to heat them up. And a lot of us, you may recall, is that when you heat something up, the particles start to vibrate. And there's some kinetic energy to that. And so as you heat them up more and more, there's more and more energy there, and they can overcome the repulsive Coulomb force and have a chance at fusion. So temperature is critical for having a chance at fusion. Plasma density is also very critical. And one way to kind of like look at this is you can't just have it hot. You have to have collisions to have that fusion. So you need to have the energy in the form of temperature usually to have a meaningful collision, but you still have to have those collisions. And if you imagine a room at a party and people are kind of moving around, there's two people, there's no collisions whatsoever. If you had hundreds of people in that same room and they're moving about, the chance of a collision's way higher. And so it's still a probability or numbers game. So you got to have them hot so that the collision's meaningful and you get a good chance at fusion, but you need to have a good chance at a collision too. And the more collisions you have per unit volume, then the more power that you can produce. You've got to get that plasma hot. That increases the chance of fusion. You got to get it dense so you have lots of chances of collisions. And as you imagine, if you're packing these things all together, you're trying to get them dense and they're hot, which wants to make it expand and cool. Being able to have it long enough to do work for you is a challenge. And the longer you can have it do that work for you, hot and dense, the better. And that's a big challenge for this plasma. So confinement time is your ability to get it stable and keep that plasma hot and keep it dense before it escapes and takes that energy with it or cools down. So confinement time is critical to keep the plasma at the conditions where it does the stuff you want to do. There's a lot of challenges for fusion. There's engineering, there's operations, there's supply chain. There's a lot of different things that are challenging there. But one key one that people will be looking at very often is the scientific ones. And it's really where all the engineering and the operations comes together to create a fusion plasma. And you want to know how good that plasma is. And we could talk about hot, which is really important. And you could talk about stable, which is really, really important. And you talk about density. But you can get a real quick snapshot at how the whole plasma is by looking at the triple product. There's other factors there that you need to take into consideration, but that bakes in a lot of the work into a quick metric to say, hey, I think I've got something important here.